Have a good day.
I took a shower this morning and I like almost passed out.
Well, I do that all the time. I stand up and it really
Like, and I was supposed to take iron pills for it, but they make me like really sick, like nauseous. So I can't take them. So I'm like kind of at like a sense of loss. I feel.
Are you teaching the whole like the whole class period?
Depends on how you define teaching, I guess. I mean, I'm not lecturing the whole time.
Okay, yeah, that's what I mean. Like after, can I go to like my counselor's office? I just found out that like the set thing is due, and my counselor never like met with me, but I signed up.
You'll just need to bring it past me.
Okay.
All right, if I did not get number 91 slope fields worksheet in Google Classroom, I need it with your name on it in the basket, please. And then we're going to start with 92 that we started last time, so you need to find that one in your binder. It was one that I said you would need a blank piece of paper for, so it might be on that. But we're going to work a little bit more on 92, not too much. We'll focus on that completely tomorrow. And we will look at the other small topic in this unit, which is on exponential growth and decay, and it is handout that you picked up on your way in, 93. Okay, more slope fields. Okay, so again, 92, we started on this just a little bit last class. I think we did like the first 4 and then maybe question 8 and 9, I think. So I was just trying to introduce you to the most challenging question type from this unit. So I want to continue on with that today and do a little bit more. But again, tomorrow we will focus just on that one task. So I'm just hoping that seeing it a few different times makes it more manageable than just spending one full class and then hoping that it all kind of clicks. Okay, so question number 5 is one that asks us to find a general solution. So one thing to keep in mind with all of these question types, they certainly vary in length and difficulty, but all of them have you separate the variables, which is why it's called separation of variables. All of these you have to integrate. All of these you have to deal with C, and all of these you have to solve for Y. Okay, but on question 5, we're going to do 5 and 6 for the general formulas, and then we'll do question 10 with the particular. So we're just looking at 3 more today. We'll do the others tomorrow. Okay. Ben, you want to give us the first step here? How would we start question 5?
Turn the y prime to dy dx.
Thank you. So to separate the variables, we've got to be able to see the dy and the dx. Okay, so you don't have to do that on all questions. The first few we looked at were already written that way, although that's not really that challenging. But all questions will need you to separate the variables. This is about as easy as it gets. The y stuff is already on the left. Multiply both sides by dx, and all the x stuff is on the right. Now, technically, I guess you could divide the -8 over if you wanted to, but there's no reason to, so to me that would just be more work. I leave the constants alone. Now, what is the purpose of separating the variables? Alright, so then the integration will work out nice and neat. So that, if you understand why we're doing that, it's more likely that you're going to be able to do it. Now, the integration, of course, is going to vary. Sometimes it's just going to be undoing the power rule, and worst case is it's going to be u substitution. Not that we can't do u substitution, but we have to slow down a little bit. This one I'm going to cheat on just a little bit. I would still probably recommend that you guys do u substitution, but what do I take the derivative of to get cosine of something?
Negative cosine.
The derivative of negative sine would be negative cosine.
Oh, sine.
Just sine. But if I take the derivative of sine pi x, is it just cosine pi x?
No.
How come?
Chain rule?
Okay, so do you see how it would create a times pi that I don't want?
Right.
So you can divide by pi. If you don't like to do that, that's totally understandable. That's what u substitution does, so that you don't have to try to think of that. But usually, sometimes if it's only one step, I will try to do that. Just check Sine of something is cosine of something. Because of chain rule, I would multiply by a pi. So if I divide by a pi, those cancel, and it gives me this. Okay, what else did I say is going to show up in every single question?
Let's see.
Okay, you have to deal with C. In the general solutions, like questions 1 through 7, you pretty much just have to remember that it exists and put it on there. On the particular solutions, we have to do more work. That's more of a pain. But all right, and then the last part to all of these question types is what? Okay, and how would I solve this one for y? Multiply by half.
Multiply by 2.
Multiply by 2, okay. I'm not sure y'all could have made that any harder. Multiply everything by 2 gets rid of the half, and then how did we get rid of a square? So sometimes the separation is going to be harder, but at least it would just be algebra. Sometimes the integration is going to be more of a pain if we have to use U substitution. Sometimes dealing with C, if we have a initial condition like the bottom of this page, we actually have to solve for that, so that's more work. And then occasionally solving for y can be more difficult than just undoing a divide by 2 and undoing a square. But this similar question, or similar format from question to question. Are you guys?
If you were to do chain rule, would you still divide the -8 by pi?
Yes. If I take the derivative of this, it's going to multiply by a pi that this one doesn't have. So I need it to go away. So again, if you have any doubt at all, just do U substitution. U substitution, when you solve for du, you would do 1 over pi, and it keeps up with all of that for you. So you don't have to do it in your head if you don't want to. Okay, let's look at one more of this type, and then we'll do one of the particular solutions at the bottom, and then we're going to move on to the other topic today. So what was the first thing we did in question 5? Okay. And then what was the next thing? Okay, we can multiply both sides by dx. What else? I didn't understand any of that. Say it again.
Can't integrate it, can you? Yeah, because there's x.
Yeah, you don't want to integrate this. It's got x's to dy. That's going to complicate things. Divide both sides by this x stuff so that we've got x's on one side and y's on the other side. The purpose of separating the variables is to make this integrate nicely. Now, I think this came up in our class last time. If there's no number here, this is an understood 1. So if I integrate 1 dy, what is that going to be?
Y.
Y. How do you know it's y and not x or r or s or whatever? Because of dy. That's really the first time that you've seen y is so important to keep up with that. Okay, so to integrate this one, unfortunately, it is, I'm going to put a plus c here so I don't forget. Unfortunately, that's not just something I have memorized, and it's not just undoing the power rule. So, worst case is sometimes we're going to have to pick out a u, solve for du, think about what we have versus what we want, and how do I make a 2 become an 11?
Divide by 2, multiply by 11.
Divide by 2 makes it 1, multiply by 11 makes it 11. So multiply by 11 halves. All of that so that we can rewrite this guy as u to the -1/2 because it would be in the denominator, 11 halves. I know I'm going over that quickly, but that's not really our focus. Pick a u, replace all the parts, make sure all your x stuff becomes y stuff. Raise the power by 1. And then raise the power by 1. Divide by the new power. Dividing by a half is the same as multiplying by 2. So those are going to cancel. I really just like to keep up with the plus c on the right, personally. And we shouldn't call this u, we should call it right, what that was equal to. So that's going to slow me down a bit, but now I have integrated both sides. And what is the last step in these question types? And this one is already solved. So the integration step was a little bit more, but the solving part was finished for us. The original equation would be 11 square root of x squared minus 16 plus there could be a constant. So again, just like Tuesday, I don't expect you to feel 100% comfortable with this, but the overall flow of the problem, the things that's going to be consistent per question, the ways it can be more difficult, are we okay with the big picture on this? Yes?
Yes.
Okay, then let's look at one more, and then we will worry about this stuff tomorrow. I'd like to look at question 10, and this is a long one. I think I'm going to show this one to my pre-calc class tomorrow, so I'll scare them. Okay, so this one gives us this, and what makes it a little bit harder is it gives us an initial condition so we can actually solve for C in this question. I know I kind of told you the point breakdown when this is a FRQ. These also do show up as multiple choice. Not a ton of them on the AP exam as far as multiple choice because they're kind of time consuming. They usually make them the quicker versions if they're going to do that. But when we get to our next test here in a couple weeks, we will have a few multiple choice questions. One thing to keep in mind about that though, even though our test on this is not for a couple weeks, next week I only see you guys once. It's an A week, so Friday's an A day. I would see you Tuesday and Thursday, but Tuesday's the ACT, so I haven't seen the schedule yet, but if it's anything like previous years, I may only see you for 10 or 15 minutes in the afternoon, so Tuesday may be a wash. Okay, so the only thing harder about 10 than question 5 or 6 that we did is we're actually going to have to solve for C, so we just need to make sure that we can do that. We still need to change y prime into dy dx so we can see how to split up the variables. Splitting apart the variables is still going to be some algebra. It's just that I can't just do it in one step like sometimes. I would probably add this over. Maybe divide both sides by the square root of 1 minus y squared. Divide both sides by the square root of 1 minus x squared. And multiply both sides by dx. It takes many steps to separate those variables. If you need to do it over more steps, then that's fine. But when this shows up as an FRQ, typically they give 1 point if you just separate the variables correctly and know that you need to separate the variables. The reason why we separate the variables is because then the integration works out nicely. Now, how am I going to integrate this? You would have to do u substitution, and just to value your time here, we'll just pretend like we do u substitution here. Just trust me that it comes out to be this. But even though I did u substitution for this earlier today, why did I not do u substitution on this?
Because it's the same thing.
It's exactly the same thing?
No, but like the x.
Right, it's going to integrate exactly the same way, right? So you really get 2 for 1. So obviously I don't want to do u substitution if I don't have to. But at least if you do it carefully on one side, the other side is the exact same thing. Now on FRQs, this is either 1 point or 2 points. Sometimes I give 1 point for integrating the left side correctly. Sometimes I give another point for integrating the right side correctly. My guess would be they'd probably only give you 1 on this question since it's really the same integration, but it just changes question to question. All right, what else is incorrect about my integration? Plus C. And they often give you 1 point if you remember plus C. So even if you integrated wrong, you get a point for saying plus C. Okay, if we're given an initial condition, we can actually solve for this c. So this is what's different than the other two that I did for you earlier. My rule of thumb is the second that I see c in an equation, I just go ahead and plug this in and solve for it right away. In theory, you can try to simplify this sum and then solve for c. It's just that wherever you plug this in to start solving for c, that's where you need to plug it back in when you're done. So, just as a general rule of thumb, if you don't have to worry about it, just always plug it in the second that you see it. If I plug in 0 for x, this goes to -1. And if I plug in 1 for y, that all goes to 0. Oftentimes, they will give you a point if you solve for c correctly. So as far as an FRQ goes, this could already be 5 points. The last point is always going to be the hardest, but we are actually finished with calculus. So since I plugged in 0, 1 at this point, this is where I need to plug this back in. C is 1 based on where I solved it there. Okay, and then what is the last step for all of these question types?
Solve for y.
Solve for y. And this one's not particularly hard, but it does take a few steps. We can multiply everything by -1. How do I get rid of this?
Square.
So if I square all the left side, I have to square all the right side. You don't get to just square this one and then square that one. That's not how FOIL works. Square the whole right side. How do I get rid of this 1?
Plus 1. Minus 1.
So take away 1 from both sides. How do I get rid of the times?
Divide by -1.
Or multiply both sides by -1. And how do I get rid of a square?
Square root.
So as I said, this is kind of a long one. But these last 1, 2, 3, 4, 5, 6 questions, all I really did was undo times -1 by divide everything by -1, undo square root by squaring, undo times by -1 by dividing by -1 again, and then undoing a square with the square root. So it looks, from here on, looks like a ton of work, but those are actually some of the easier steps. But all of these questions, separate so you can integrate, solve, deal with C, and then solve for Y. All the questions, regardless of how difficult they are, will follow those steps. Okay, we're good with this?
Yeah.
20 questions, no big deal? Okay, so we still got a couple more to do of this, but that's the first thing that we will do tomorrow. We'll finish up the notes together, and then I've got some practice questions that I will have you do, and we'll just stay on that one skill tomorrow. All right, but the rest of what we're going to spend on today is the other small topic in this unit. The first small topic being slope fields. And to be honest with you, this last one, exponential growth and decay, has almost zero calculus in it. This is really more algebra than anything. But in this unit, we look at exponential growth and decay. Exponential growth and decay. And so we're going to look at questions that say this. Either, here's the only thing calculus that's going to show up on this worksheet. This means the same thing as this. If something changes at a rate proportional to the amount present, a calculus way to say that is with the little derivative here. As soon as you see that in a question, it's going to be this type of problem. Y is equal to y sub 0 times e to the kt. Or, might look more familiar, if I write it like this. Just the PERT formula. You got an amount, you've got a starting amount, y sub 0 just means the starting amount, e is the same number e. I don't know, some people use k instead of r, but that's just the rate, and then t represents time. You've seen the PERT formula before, correct?
Yeah.
So all we're basically doing is using PERT and some logarithm properties to answer some questions like this. Now we're going to do this in kind of a weird order. The first 4 questions on the front page are actual AP exam questions, and they all follow a similar format. I'm going to do the first one for you, but that's kind of the ceiling. That's what we're aiming for as far as difficulty goes by the end of class. After I do the first one for you, we're going to jump to the back of the worksheet where the questions start off quite a bit easier and then kind of build you up to this. Alright, so this question says, bacteria in a certain culture increase at a rate proportional to the number present. Alright, as soon as I see this, this tells me, hey, this is this type of question. And then honestly, calculus is done. Everything else is going to be like advanced algebra. Harder than you did in Algebra 2. You might have done a touch of this in pre-cal, I don't remember. But it says if the bacteria doubles in 3 hours, so let me plug that information in. If in 3 hours, remember E is a number, not a variable, the population of bacteria is going to triple. So what do you want the starting population to be?
P.
Pick a number.
2.
Okay. If the starting population is 2, and I want to know in 3 hours how much it doubles, so how many bacteria is it going to be if it doubles?
2A.
4. 2 times 2, 4. But if you do that, they didn't tell us to start with 2 and end with 4, but regardless of what you pick, do you see the first step would be divide by 2, and you would end up with this? So I just always pick 1 and 2. I don't know what I'm starting at, but if I want it to double, it needs to be twice as much. If you want to pick 2 and 4, you're still going to end up with 1 and 2 after the first step. If you pick 1,000,000 and 2,000,000, you're still going to get 1 and 2 after you divide both sides by 1,000,000. Okay, so now I've got this. This is just a 1, so I'm not going to put it there. I've got enough information that I can solve for the rate. But you have to remember 2 logarithm things. Number 1, the only way to solve for a variable and the exponent is with logarithms. And there's no logarithms here, which means we need to introduce them. So I'm going to take the natural log of both sides. And that's fair to do because I'm doing it to both sides. Why is that good news over here?
Because natural log of B is just 1.
Okay, but what happens to this before we...
Comes down.
It does. It comes down. The special thing about logarithms is if you have an exponent on something you're taking the log of, that exponent can come down out front. Natural log of b we know is 1. So r is really this. Now this isn't what the question's asking for, but I need to make sure that you guys are okay with this. You can only bring this down out front because of a logarithm property. An exponent on something you take the log of can come down out of the exponent. Y'all remember that? Would you remember it if I didn't remind you of it?
No.
Okay, this is actually what we're doing in pre-cal right now. So their daily meme today is relevant to that. So if the website will work, make sure that you understand that.
Oh, that's cute. I like that.
So if this was an exponent on something you're taking the log of, the exponent can come down out front.
That's nice.
Right? Same thing that we're doing. Okay, but this question didn't ask us to solve for r. This is why this one's a little bit harder, and this is what we're going to be building up to on the back page. The question comes back and says, how many hours will it take the bacteria to triple? Well, I'm going to restart, but now I know what E is. so I can actually plug that in. How long? Sounds like I'm solving for t.
You know what R is?
Yep, that's what we just solved for. Okay, E is just a number, it's not a variable. And then if I wanted the bacteria to triple, what should I pick for P and what should I pick for A? Okay, it doesn't have to be 1 and 3. Yeah.
Can you pick, like when you were solving for R, can you pick any two numbers initially?
For A and P?
Yes.
Yeah, we actually started with 2 and 4, but what I showed them is if you pick 2 and 4 to double, your first step should be to divide both sides by 2, so then it becomes 1 and 2 anyway. So if you wanted to triple, it doesn't matter if you pick 100 and 300, your first step would be to divide both sides by 100, so you would still end up with 1 and 3. You're just adding a step if you make these bigger. If you want it to be triple, just pick a number for the start, make it 3 times bigger for the end.
Well, when you solve for R, like when you're solving for if it doubles, wouldn't that give you the rate for it doubling, not tripling?
But it increases at a rate proportional. Because of that, it stays the same. Okay, so now we've got, this is just a 1, so I'm going to erase it. So now we can solve for t. What's the only way I can get this t out of the exponent?
Natural log.
Okay. Well, really any logarithms, but in calculus we always use natural log. And the reason why we take the natural log of both sides is now this stuff is an exponent on something I'm taking the log of. So all of this can come down out front. Natural log of e is still 1. And I'm going to multiply both sides by 3 and divide both sides by the natural log of 2. And that leaves us with answer A. So this, again, this is what we're aiming for at the end of this, so you don't have to feel like you're here right now. But this is what they expect you to do on the AP exam. It's basically a 2 for 1. You've got to use the PERT formula to solve for rate or something else, just to plug it in and redo it and solve for something else. So if you can do it once, you can do it twice. But finish copying down what you need to there. And I am going to ask you to do the other questions on the front page, but first I think it makes sense to do the back page because the back page is quite a bit easier and it builds up in difficulty. So you will need a calculator, but go ahead and try question 1 on the back page, and again it should be very simple, especially in comparison to this. And for those of you that work very quickly, you're welcome to look at my solutions online and make sure that you're on the right track. I will ask you to finish this for homework, so it is in your best interest to stay on task here. But for the first couple here, if you don't want to pull up the solutions yet, I will post the answers so that you can quickly make sure you're on the right track before you keep going. And this doesn't really say how to round, so please just go ahead and round to 3 decimal places, just like you do with the FRQs. The AP exam will expect 3 decimal places all the time, if you round. Okay, again, all the solutions with some work is on the website, but there's the answers to quite all parts of 1 and 2. So let me give you time to try those, make sure those look okay, and if you're not getting that, make sure that we get that ironed out before you keep going, because they will start slowly building up in difficulty until they're similar to the questions on the front page. come around and help here in a couple minutes. I'm just trying to grade a couple of these homeworks so I can get them back to you today. Bless you. You okay?
Yeah, my calculator just broke.
No, I mean you've been having trouble finding class.
Oh, I've been going to my counselor. He keeps calling me like right when chemistry ends.
Oh, I thought you were just lost.
Oh, no.
Did you turn in your homework
Yes.
without your name on it?
Maybe.
That doesn't sound like true.
I saw you turn it in. That's the reason.
Thank you.
part of the formula is right. Large. Okay, so where's R and what they did is where's R and Okay. What's that other one?
2%.
Okay. And it didn't work for it.
It's cost rate.
Kind of weird thing that you have to solve.
Okay.
If you turned your homework in the classroom, if I saw any mistakes, I put it in the comments. If you turned in hard copy, make sure that you look at it and you plot the points. So for questions 1 and 2, all the parts, please let me come and help you if you're not coming up with those answers before you move along. Because again, the problems will just get more difficult. So if there's something you're overlooking, not typing in the calculator correctly, anything like that. What are you trying to solve for?
See the rate, I just don't know.
Okay, so what variable is the rate gonna be? Okay, where's R in the formula?
2.
Okay. What's that as a percent?
2%.
There's your answer. It's right there, you didn't have to solve for it. We have some real
Is half
calculators
of in the equation? Is it? Yeah, I don't know. I think a way to judge it on life, I
I
just.
have that on my, I have one like that on my phone too, but I have to,
I mean,
like, I have to aim below the
after
button.
each period of time,
Yeah, that's
half.
right.
It's gonna half of that, then half
So
of
it kind of
that.
relates to
Exactly.
But it does
You can
work.
calculate it with my hands.
Like, it's like the same thing as the calculus, so.
That won't be hard, just a very tedious process. Because let's say if you have a half-life of 2 minutes straight, and then you watch it for 12 hours, it's not like that.
Yeah.
Okay.
That's very fun. It like looks like it, but not like that tricky. I literally left it, so I was like. I don't, how do I use this? Number of years, okay.
Okay, again, all these are on the website, so those of you that are trucking along here will probably need to pull those up. But I did at least write number 3 up there to delay it a little bit.
You got it. That's funny. That was funny. I'm gonna use the one that you can do now that I know what it is. How are you using that for though? You're like cheating. That's less than genius. That's such a hack. You're so stupid for that.
Are you gonna do the weekend? But no, it's usually so we look at 100 is good. It's 130. 130 is here. Today is or switches. Okay. Are you going to start it? You got that right there. Okay, that makes sense. Yeah.
Let's
So now,
find the initial mess, but
ER is
plugging
do we know rate? Was it that's in 1 hour, so it's just 1 hour's time, right?
Yep.
So that's all that.
No, wait.
Okay.
So I think 10 is gonna plug everything back in. If you plug in negative 0.009, that times 0, that's just 0.
No, I need
Power
zero.
of 0.
Okay, I see what you're
Is
saying.
1.
Okay.
Well, to me, I just saw 10, so maybe that was the answer.
Okay, got it. Yep.
Yours is like exactly
What'd you get for filler?
No, I just remember.
For mass, 1470.
Yeah, that's fine.
One's like, no, you can keep it as one. You can keep it as one. So, but you have to, it's better to do both of yours. If you make estimates, you have to do that. Well, you take the natural log of this side, all of this side. Yeah, you should divide first, so that's gonna make this a 1 and a 2. You always want, then when you take the natural log, you see how you take the natural log of the whole left side, but then the right side, you only take the natural log of the part of it. So you do the whole right side. 6, 4,
that was my rate.
10,000 times by 1 and this is
10
what
hours.
you do, and then take the natural log.
No, my rate is,
And then flip that 60.
I don't know if that's enough, but try that first.
Yeah, and then once I got there, I would be.
Get 1998. I don't know if that works in a year.
It does.
I didn't do year, I just put in how many years, so yeah.
To find the rate
Are
rounded to the nearest 0.1%.
I think this one, yeah, 1998, 1641.
Is that question in terms of hours, I'm guessing? Because that would be hourly. So they're asking you to solve for R, which happens to be in terms of hourly, within 0.1% rounding. What did you get for your answer? 34. Yeah. What did you get? 32,
Okay, I slid it up and oh, I did not. I slid it up to share a couple more. I will tell you number 4 kind of has to be done in 2 parts, like I did on the question on the front page. You've got to solve for R, and then start over and solve for something else.
How do you do C? Or how do you?
Okay, for which one?
This one, sorry.
Okay, so when you write out PERT, what part of the PERT formula is the rate?
R.
Okay, so if we compare that to this, where's R in there?
0.02.
Okay,
Oh, so is that it? Oh,
but write it as a percent.
2%.
Yep,
Oh,
it's right
okay,
there.
Thanks.
Why do we use that and not the, why do we use 2% and not this times 6 and then times 3 for this? Why is this not the rate, but this is the rate?
The rate is just that part of the exponent, the R part of the exponent.
And then what is this? This was when I plugged 6 in for T and then did this, but I didn't multiply by that yet.
Well, if you end up multiplying by that, then that was gonna tell you
Isn't this my rate of change over the 6 days?
your rate is 2%. Right there. That's R. Right, that's percent. You don't even have to do anything. They already found it and plugged it in for you. Like up here, which one is eight?
R is this, that's your rate. You plugged it in as a decimal in place of R, but just now you're doing it backwards.
They're giving you the formula, R is right there, you picked off, so it's 2%. The rate is only the part of the exponent, not times t to the power b, not all of that.
Okay, what's the initial?
This question.
Let me double check my math, because of my.
That's, yeah, that's the one.
If it doubles, if it doubles in order, that's how. So I did this in a rate, and
It's
that
an
means,
exponential rate.
and on this one, it says mass be 10%.
Okay, right here, I'm gonna remove the natural log on this side.
The amount doubles in 1 hour.
You can't just take the natural log of the right
Doesn't
side.
that mean
Double
double
off
the
the
hour?
even it balance and take the natural log of the left side. Maybe rate should not be 1.3, it should be the natural log.
I don't know.
Would this be, if it's doubling in 1 hour, does that mean it doubles every hour? Could you assume that? Since it's a constant, or it's
I
proportional
think
to the
so,
rate?
but I don't know if I would go with that. I think I would work it out.
Okay.
I think you might be right, but I'm not 100% confident.
Okay.
I think there is.
What part of the question are you trying to do? Like how many times?
If the amount doubles in 1 hour, how many times the original amount would that be?
You can go ahead and try it that way. I think the answer is 16 times the original. So you can try it and see if you get 16 times. How do you do it? How many times is it doubling? You usually put it
Why wouldn't it be 8 times the original? Because it's like, if it, after 2 hours it should have 4, after 3 hours it should have 8. It's doubling every hour.
So you just,
Because you're starting
don't
to
say
see,
times.
assuming you
Oh,
start
it is
the
in?
population of one.
I don't have the answer.
It'd
Right,
be
that's why there was 16
2,
times.
it'd be 2 to the 3, right?
Yeah. So I guess you're right. But what I did is I just like made up,
Second part of that.
I called the initial number
47 years.
P, worked it out, and then I think it was 8P in the end or 16P in the end, so then it was 8 times or 16 times, whatever it was. So you
How
can
did
still,
you write it down? How did you solve it?
same way as these,
So you did
write out the PERT formula and plug in some information.
A equals, just like, I could put 2 right there and I could put 1 right there, right?
Well,
And it equals R to the,
that's what you're trying to solve for in this question now. Don't you have R and T?
you don't, or, yeah, you have T, but you don't have R, right?
Have you done?
But you can still, you can solve for R though.
You know it doubles? Okay, yeah. So yes, you could use this to solve for R.
And then you plug R in for maybe 3 hours. And it should be 8, right?
Yes.
Like, here it says 0.1%, does this like mean that the rate is 0.1%? I mean,
Since this is in terms of hours, this question is in terms of hours, and this is saying hourly,
Very cool.
they're wanting you to find the rate within 0.1%, so they're telling you how to round it.
Oh.
They're just telling you how accurate your answer should be.
okay.
So instead of doing 3 decimals there, you can just do 1.
Or, I don't know.
What's the rate?
I got this one.
69
I guess we keep it
69.3%.
You had to change this to the decimal.
Find that R equal
If you change that to the decimal halfway through the question, this is a little bit wrong. Which is gonna throw your final answer.
the hourly growth.
We don't want to round to the very end, so don't change that to the
What is
decimal,
it?
just leave it natural log of 1.3. Very, very down. Only round it.
What, the second part?
There.
If, as you know, after 1 hour, it doubles, so I put 2 right there, I put 1 right there. And I knew it's, the time is 1 hour, so I just put R.
Yeah, we should.
And then, I took a log on both sides. And a log of 2 is with R, which is 0.693 versus.
But you round it to the
Yeah,
middle
I think
question.
that's.
For 4, yeah, we got it for R. And then we plugged in that
And
right.
then now, wrong
That's
last one,
a
would be
FRT,
20
you're not gonna get the
is
answer
equals
like
root
that. It
1.
needs to be within 3 decimals. So you need to actually keep it exact.
Okay.
And whatever you rounded here,
Yeah, I run it to 266.
just leave it this until the very, very end.
Okay.
Leave it natural.
20 equals.
The other issue is, even if it's multiple choice, like, you might say, well, there's an answer close to this, so I think that's it. But how do you know it's just a rounding
Take
thing
the
that
log
didn't make a
for
difference?
both sides.
Yeah.
You wanna keep it exact for the very end.
So, log. Log 2.
Grade 2.
That was good. You solve for R, and you gotta start over.
Would you get through your, Well, you still know we should be starts for a little bit. Still use the 100. So now you know what R is, and you know what time it is. So you can solve for A. So you're ready to throw it on your calculator. You did all the hard part already.
Back page. You good?
I got 4.322.
Yeah, I got that.
So 4.322.
Okay. Yeah, 4.3.
For number 7A. Okay,
It's not
well, do you have a rate?
natural log of 18.
I think you do. You have time, 20 years.
I don't see why would it.
Okay.
Oh, this?
That, why is that not equal to that?
Okay, so
I don't
you're working
see
with part A or part B?
Isn't that illegal log properties when you're dividing?
Is that the answer?
Yeah, I think that's the answer, I think that's the answer. to the
No, I
question.
think it's when you.
16 times whatever you.
No, I think it's when you subtract two logs. It's gonna be like log number, like log of something over something.
Oh.
Space.
Yeah.
Yep. It might be a few minutes. Let me get you the backup test.
Did I just put it in the calculator?
Oh. If I can find it.
You said to finish and return, and I finished. Good. Let's go.
Oh, because.
You did it separately.
This is not a real hub pass anymore, but use that for a minute.
Got it.
When you make it to the front side, those first 4 questions are all actual AP questions, and you'll see that they kind of follow a similar format, so you'll know. The AP exam's not going to put more than 1 or 2 of these on there, by the way, but I still want you to be able to get those points, especially because we're not having to do any calculus here. No derivatives, no integration, follow a similar format. But one thing you may notice is that 2 of those practice questions or release questions were from BC, Cal BC, and 2 of them are from AB. But the BC ones are not any harder than the AB ones. So.
What did you do for the initial population? You just want-
Speedies.
Then, yeah, just move on.
Yep.
One thing that I think is interesting about this lesson, y'all may not care, but a couple years ago, I think this was the last lesson that I taught to my group. And then they went away for COVID, and I didn't see them the rest of the school year. And some of these questions are kind of about that type of topic, so it was very kind of strange. Especially that bottom question on the front page.
Yeah, but like the infected.
Is that
Yeah.
There's an epidemic going around.
It's a very small city.
It was very strange timing.
Numbers.
7.
No, I like.
That's a real time scene.
That's a really small city. I don't like that. I do not. If that appeared on the AP exam, I would second guess myself and just
Yeah.
pick a random number.
Oh yeah, they probably gonna try to screw it up or because they can, because it's funny to them.
Yeah.
No, because that's what the ECP does all the time. They just want to screw it up. Oh my god. Some competition. Usually the front page is good.
Yeah.
That's probably, that's a good thing we should probably miss out tomorrow for the lab.
I don't have a period bar, so I'm hanging up.
So basically, the time it takes for 2 particles to turn into.
That's the half-life.
Yeah. Okay. So the time it takes for 2 particles to turn into 1 is so then you just plug it all in. Then you're gonna go to natural logarithm. Well, no, natural logarithm. Yeah.
We can still have Q Monday? Monday.
The lab's due on Monday.
Oh,
We'll be doing it on Monday for
oh, okay.
There's
I wasn't doing the pre-lab then.
I have it out.
My bad. You can read the one that's exponential growth and
You have to figure out the steps.
Oh, we just predict what's gonna happen.
Yeah, you have to create the steps you're gonna do to make a certain time.
Oh, never mind, that's ain't that hard. I really have to find time and assemble to make a lab. That's actually pretty simple. It's still talk about the processes and processes and
But like, you have how do you do it?
Yeah, on,
We did get them all right, Mr. Town.
You did?
There we go.
Yeah.
Wait.
After how many
You
tries?
doubted us.
Well, seeing how you had trouble finding your way to class.
What did you get for the 70?
You did a
7,
It taught
47.
The answer to 5
You're right, it's like the same thing.
Okay. I was wondering, because it looked like a 57.
confused on this.
Oh, no. It's,
You're right.
yeah.
I don't know what I'm talking about, I got it wrong.
Yeah, you might want to pull up the solution.
You're gonna
Wait.
I'm off by
But it's the same thing, right?
Did I show you I have a picture of your brother over there?
What?
I used to do my fitting trials up here.
Oh. That's a good thing.
You keep the seating charts?
Yes.
He aced pretty much all of our tests.
I'm not surprised. Who?
Thomas needy.
Will we get one of those? What do you get? Seating chart. Well, yeah, like it was like the old years behind it.
Yeah.
So will we have one of those? You'll be up there.
I mean, I have it computerized somewhere.
But like, will we be printed out?
Someday I'll look back
Cheers.
and be like, man, how did I survive that class?
Yeah.
Did you need to print you one out?
Well, you printed it out. You printed.
That's from years ago, though.
Or like,
That's how I used to
or
tell
like, sorry,
people
the
where
last
their
one
seat
before
was.
that.
Right, but like, think about it. This will be years ago soon enough, right?
Judah has.
So you might as well print one out and
Hey,
vote
Judah.
for us.
You
Come let me see the last one.
Harrison just wants to come back and see his face.
Our face, friends, ours.
Harrison's gonna teach you.
Why did you do 1 = 2 equals better? Like, I don't understand. Take it back again, it's not fair. It doesn't make sense.
You lost.
You're lost.
I just need to finish this last one.
It was the same year I had this class, but I may not have turned out our file at the start.
Well, I know she tried to use 0 hours.
Oh, sorry.
Oh, you need this because then you get, yeah, that's. Well, yeah, because then you count your technical route, like straight up.
Maybe because of 0, you'll also
That's
so bad.
I changed their signature.
That's 12 years. That's 12 years.
Nothing I did work.
Like, no, they're like, I failed the category test.
Yeah.
Like, I
Anybody want to
can't-
get salsa on chess? I felt really good about my guess.
No, like,
You want to get salsa on
okay,
chess?
I thought
Get in a game right now, my
I
friend.
didn't
I didn't answer mine.
Crew's
I
scared.
didn't
Crew
know how
won't
to do
put it
the.
back. I keep telling my wife we're putting it back.
I need to
The
do
last
ice.
one.
Okay.
No, like,
I've been playing on
second
it.
FIQ, and then
Oh,
yeah,
on
I
it today?
know.
Yeah, that was. I know.
I couldn't get it.
I didn't know how to ice.
I don't know how to
I could get it.
So I don't know.
Like what?
I don't know how to open.
I just put it
No,
like
you
random
just
numbers and I plug it into the equation.
Yeah.
You don't get
Pros.
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 You don't have to ask for this.
Oh, what were you talking about? What were you saying?
You're not solving for A. And it's a very small town. It's got 14,000.
Standing bowl.
What's the name?
Standing bowl. Well, yeah, there was like a email for it. It was like sitting bowl. Or something like that. Yeah, sitting bowl.
Or it's not, are they like barely low the system still?
Oh, you mean, yeah.
The only thing there is the restaurant.
Okay, come on, Billy Jeff.
Let's go, man.
Come on, Billy Jeff.
It's not around here, it's in Central.
Are you starting it?
Yeah, I got you. Hold on.
That's pretty small.
You ready?
Yeah.
The first part of this question is just in 1 hour.
Oh my gosh.
Oh, 3 minutes, dude, sorry.
We gotta go. We gotta go.
You have to go to the other town.
You plug in along with it. There's 2 parts.
It's only like, it's like 7.
Bro, we have the same strategy.
Oh wait, did you have, I think they have, I think they also have a community, they have like a town center.
So they're saying.
Not only that, they're pretty impressive though when it comes to like holiday decorations. Like they decorate for the holidays like the entire town.
Obviously, that's not.
What else could you, what else is there to do?
That is the rate, but they're not. Accuracy, I just had.
Or just 1 hour, right?
That's the first thing it asked for. Okay, now that you know what the rate is,
you can figure out how much time we need for it to be 20 times the original amount. So just make the original 1, make the ending amount 20, because that would be 20 times the touch. Plug in your R that you have. And then all you need to solve for is E. So that's what you need to solve for the second part of that question.
Is it me or you?
That would be a rate if it doubled in 3 hours, because you're plugging in 3 for E.
Did I
It only doubled in 1 hour.
Right. Did I also get that right?
Now, you haven't finished the second time. You haven't finished the second part of the question. You still need to solve that.
Teacher and homeroom. I heard about you guys, your guys' views.
You got that question you can solve for Q, that's the second thing.
I know basketball.
Do that and then check your answer.
Yeah, basketball practice. How many times was that? Are you shocked?
No.
You looked really shocked when I said that.
You're aggressive. No, I mean, help.
No. I'm talking about the stuff.
No, like it's really okay.
No, it's okay. Don't worry about it.
No, like it's really okay.
She said this is just a calculus way to say.
Go to thinking.
This type of question. So you still want to use but that's how you know that it's a per type of question.
So I guess use this.
All this is doing is telling you that you can use this one.
Oh.
You don't need to, yeah. Because without that, you can't just assume that it's this question type without being sure. Yeah, you can just use this. The population doubles every 10 years.
That was so sad. I spent
So you take the starting,
5 hours.
double for ending, and you've got
I still
time.
didn't do it.
And I want you to solve for K, which is just a different one. So you can still just do for.
I think the last one was a lot.
I didn't try on that one.
Well, there's like some.
No, that one's not easy.
But it's not like.
I mean, dude, I'm probably get like, I'll probably get a 70 on this one.
Why?
If I'm thinking correctly.
No, that just refers.
Let's see what that'll draw my grade.
It probably wouldn't.
What? Don't do it to me. I won't do it to you.
Yeah, it really costs
It's
millions
just,
of dollars
what?
to write those questions, like ACT too, because
Okay, so
they have to like give them out to people and then analyze them and make sure that like, if some question is like 55% of the girls get it right, but only 45% of the boys get it right, but there's something about the question that's distracting. Like that could distract people, like if you have family members or something that like, so that's why they probably like do that. But not because there's like anything wrong with talking about it, but they just don't want it to be a distraction.
Huh.
Yeah, and they have to make sure that all that stuff works good before they assign college credit or
What do they do?
ACT
They
scores.
just have like a sample population to do the test or something?
So if, say you had.
Yeah, trying to remember. I think on the ACT they used to maybe give like extra questions.
I know they still do that.
Okay, they did, yeah.
The
So
test
they-
under section
yeah.
5.
Yeah, so that's what they're doing. They're just analyzing and making sure that like, it doesn't matter about your gender or your race or whatever, like it's consistent. It's still a fair question. For AP, well, I think with AP they may not have to do that as much because they scale it.
Yeah.
So like it's just like the ACT. If they give you a really hard version,
No curve.
right? Yeah, you need a lower score to pass. If it's a really easy version, you need a higher score to pass. So you don't necessarily want one that you're like taking and thinking, man, this is easy, because it might be easy for everybody, and then the cutoff score is going to be higher.
Yeah.
So I think they get around that in that way.
And they probably also have some leverage, so like where they could throw out some questions if they needed to and then recalculate. They keep a lot of that secret, so that way they can do things that they need to do, I think.
Okay, you guys only have about 3 minutes. If you did not finish, please finish up. Be prepared to turn it in tomorrow. You can turn it in to Google Classroom early if you'd like. And if you need help, come see me during advisory.
If it's Half-Life, do you put 0.5? Still can do it also.
Half-Life means all the time for it to pick up half. You start off with 10 and then first thing you're going to do is divide by 10. So you're still going to get 1/2.
Why would you do that? Why would you do that? I'm just trying to go. Why would you do that?
You could have taken like full.
I was thinking about the whistle button on there.
Bro, stop being a stinker.
Like if I'm sitting here or something, I'm gonna need y'all to like say something on the microphone for me, like just me on the test. Sit down and shut up. And I can just have a little button. I think that would be fun.
Wait, you can program it? Like,
You just place it down. So you can get the computer to record it.
yeah, and
3
then
seconds
put it
down.
in there and then just
Oh, stop trying to corner me.
I don't know like which ones I would want, but I think some of them would be kind of fun.
Yeah.
Except draw.
was also or a thing. So he couldn't brand.
Every time this year, it's
Yeah, I got the work. Now I just got to It's software next year. Are you going to take block next year?
I'm gonna take. I was like, see what I needed to do in like a real wide design.
Yeah.
And then I just walked through all of it, but then I lost it.
You have no feeling.
Dylan, you wanna go to,
What are you doing? What? Sorry.
I got another puzzle back there.
Yeah, I actually bet.
On that.
No, like actually.
no, like, actually.
No, like for real.
It's not nearly as
Like
long.
low key.
It's kind of a neat puzzle.
Where do you want to hike? Or where in Oregon?
I wanna do Crater
Huh?
Lights.
Oh
my God.
That'd be sick.
Right there.
I couldn't play
You
it.
can just get a piece of paper.
I'm gonna screenshot that.
That's so stupid. You know I won too. Don't you know I won too.
I don't think so.
Oh my God. I had Earth.
That was so
and then I got
painful.
Okay. Jeff, I guess that's how you play chess, man.